Okay guys, so this video is going to be solving 3x3 systems with Cramer's rule. I am, however, going to go into a little bit of why it works, but I'm going to use a 2x2 system for this. This would extend to a 3x3. That's just a little bit more to kind of prove or show. This will also show why we use determinants for a lot of things. So if I had this 2x2 system, and if we were to just solve by regular old elimination, so maybe one option we would do to try to cancel out this y term is I could multiply this first equation by d and multiply this second equation by negative b. So I'm going to write here what I would have. All right, so if I was doing elimination, right, the next thing we would do is we would actually add these equations together, and my y terms would cancel out, and what we'd be left with here is this a dx minus c bx equals ed minus bf. Now, if we just simplify this, factored out our x, well, I'm gonna clean that guy up a little bit. Okay, hopefully this guy over here looks a little familiar. And hopefully the reason that is because if we had a matrix A, B, C, D, right? So if I just had this matrix, that would be the determinant of this. So we can actually express what x equals, because I can still solve over here. X would equal ED minus BF over AD minus CB. And all of these we can write or we can express using determinants. So they just figured there was some kind of pattern in solving. So they set up these matrices, these determinants, to help us figure that out. So I'm going to write over here that we would have, if we're looking for x, I'm going to rewrite that equation I had down here. And I'm going to go down the bottom first. This is the determinant of this matrix, A, B, C, D, right? Because AD minus CB, our second diagonal, would give us that determinant. So the numerator, we can go the same way. ED, I would need to be that first main diagonal. And then BF, I would need to be the second diagonal. Now, I wrote it this way, kind of in this order, because if you notice from our original system or original matrix, BD were those y coefficients, and EF were the answers. So this is called Cramer's rule, this method of solving, and they usually notate these matrices this way. This is to find x. So this is a matrix we create by taking away the x coefficients. So right here, I'm going to use a new color, and replacing with the answers. So we replaced the x coefficients with the answers or the constants in that system. And then we would just solve this to actually get what x equals. So similarly for y, we have this kind of formula that work out. I'm actually going to write the determinants first. We would replace now the y coefficients, so I would still have AC, with the answers, EF, but my denominator would be the same. And we could kind of go through this whole proof we did originally to figure that out. But that's what it worked out to be. So this would be AF minus CE over, again, AD minus BC. And that would be equal to our y variable. They notate this using kind of this notation. So A sub x would be the numerator to find the x value, a sub y would be the numerator to find the y value. So this is what we call Cramer's rule. All right, so I'm going to jump just right to a big example. We're going to go a 3x3 system using Cramer's rule. Making sure I copy this down correctly so we don't make any silly mistakes here. Okay, so like I said, we're going to solve using Cramer's rule. So the first thing I like to do is actually just write out our coefficient matrix, which I call A, and find the determinant of that. So I'm just going to take all of our original system coefficients, and I'm going to find the determinant. Any method you like, so we can use cofactors and minors. You can use the diagonal method. I like to use cofactors and minors, and I'm actually going to use this last row to find it. So I'll have 2 times that little square matrix. And again, you may have to go back and review how we find our determinants, or if you need help on that, let me know. Minus 5. This would be our determinant for that. It would be a 0 as the last one. So that's all set. And I'm going to carefully simplify. So this would be 2 times 22. Negative 13 times negative 5. So our determinant of the coefficient matrix would be 109. So we're going to use that to solve for all of our variables. So I'm going to start over here by solving for x. And we do this by finding this ax determinant divided by our coefficient matrix determinant, which we already have. So ax we find by replacing the x coefficients. So that's going to be all these guys. Replacing those with our answers. So my first row of the matrix is going to be 12, 15, negative 1. All the other columns are going to be the same as our original matrix. So these will still be the y coefficients, and these will be our z coefficients. So I just replaced the x coefficients with the answers, with the constants. And now I'm going to find this determinant. I'm going to use that last row again. That red's a little harsh. I'm going to get rid of that guy and just hopefully you guys know that I'm using the last row here. Oh, won't let me erase all the way. There we go. Now I'm sliding everywhere. Okay. Negative 1. Put my 5 back, put my 0. Alright, so solving this, I'll have negative 1 times top corner determinant, which I did have last time also. I need negative 5. And this will be 12, 4, 15, 1. 0 is not going to change anything. Gotta stop sliding around. And again, just really take your time on these calculations. This is where we could make silly mistakes. Looks like I'm going to have negative 22. This will be 48 times 5. Again, you can use your calculator to help you out, but should be 240. So I should get 218. Now that was just for my numerator. So don't forget, we're still dividing it by that original coefficient, and that's beautiful because we will get x equals 2. All right. So now for y, I'm going to do the exact same thing. So y equals, this time we're going to have ay over our coefficient matrix determinant. And this time I'm replacing the y coefficients. So from that middle column, let me get rid of some of this stuff in our way here. So our middle column, -2, -6, 5, replacing that with our answers, 12, 15, -1. Other column stays the same. Whoops. There we go, giving us a nice view. All right, so once again, I'm going to use this last row. So I'll have 2 times 12, 4, 15, 1. Change the sign for this guy. -1, 4, 3, 1, 0, still helping us out. All right, so we got this time 2 times a -48, so a -96, minus 13 is a -109, which is beautiful. So y is going to be going back to our original fraction, -109 divided by 109, which is -1. Now we've got two of our answers, x equals 2, y equals -1. Instead of doing this all over again, I actually like to just throw them back into any of the equations from our system. So like the first equation, for example, we have -x minus 2y plus 4z equals 12. I'm going to put both of these into this guy. And I'm going to solve for z. So this would be 2 plus 2, that would be a 0. So we get 4z equals 12, and hopefully z equals 3. I could very easily check this by using maybe the second equation. So hopefully this will hold true. So I'll have 6 plus 3 equals 15, and we are all set. All right, guys, so that's Cramer's rule. You can always do all 3 variables. You will have to do at least 2 variables for my directions. But any other questions, you can let me know and try out the practice.